There is a creature that can survive being frozen, boiled, crushed, and even launched into space, and it just shrugs it off. We are counting down 10 extraordinary reasons the tardigrade has earned its reputation as the toughest animal on Earth. From ancient survival secrets spanning 500 million years to molecular mysteries scientists still cannot fully explain, each entry on this list pushes further into territory that blurs the line between biology and science fiction. By the time we reach number 1, you may never look at a drop of water the same way again. It all starts at number 10, with an animal smaller than a grain of sand. In the 10th place, we must confront a fundamental paradox of scale, an animal that can survive the vacuum of space, yet remains completely invisible to the naked eye. When we think of microscopic organisms, we usually picture simple single-celled amoebas, drifting spores, or inactive seeds. But the water bear is different. Typically measuring just 0.5 millimeter in length, barely fitting on a human fingernail, these creatures are fully formed, complex multicellular animals. Under a microscope, you will not find a primitive cell, but a sophisticated organism boasting a protective outer cuticle, 4 pairs of clawed legs, a complete digestive tract, and a centralized nervous system coordinated by a brain-like ganglion. It is a highly detailed biological blueprint compressed into a frame smaller than a single grain of sand. This baseline contradiction is what makes their survival feats so difficult to comprehend. Before they endure any frozen wasteland, they must first exist within the sheer improbability of their own miniature design. They are not spores or seeds. They are tiny, fully formed animals, conquering a microscopic world. Number 9. When environmental moisture vanishes, the water bear performs its most famous survival trick, one that blurs the boundary between life and death. The animal begins to pull in its 8 legs, contract its segmented body, and expel almost all its internal water. It transforms into a tiny, dry, wrinkled husk known as a ton. In this state, the creature enters cryptobiosis, a near-total metabolic standstill where all biochemical processes drop to less than 0.01% of normal levels. To any conventional test, the animal is dead. Yet, the cellular machinery is not destroyed. It is merely paused. Biologists have successfully revived these desiccated tons in controlled laboratory settings after more than 10 years of absolute dryness, with the creatures simply walking away upon rehydration. The secret lies in a remarkable molecular defense. As water leaves the cells, the water bear synthesizes protective sugars like trehalose along with specialized tardigrade-specific proteins. These molecules act as a biological scaffolding, vitrifying the cell interior into an amorphous glass-like solid that prevents the delicate structures from collapsing. It is a state of suspended animation so absolute that it challenges our definitions of biology, showing how a multicellular organism can completely freeze its own internal clock. In the 8th place, the challenge shifts from water loss to the absolute outer limits of temperature. While active water bears live in mild conditions, surviving only brief exposures between -20 and 30 degrees Celsius, their dormant tune state unlocks thermal endurance that seems physically impossible. Active specimens can only withstand mild changes, but once dehydration forces them into a ton, the physical rules of biology rewrite themselves. In laboratory settings, scientists have frozen these dormant creatures down to -272 degrees Celsius, a mere fraction of a degree above absolute zero, where all molecular motion practically stops. On the other end of the scale, they can withstand dry heat up to 150 degrees Celsius, far above the boiling point of water. Human core temperatures must remain in a narrow band between 0 and 45 degrees Celsius to prevent systemic cellular collapse. Yet, the water bear resists both planetary extremes. This thermal defense relies on the same vitrification process that safeguards them from desiccation. By turning their cell interiors into glass-like solids, they prevent ice crystals from tearing their membranes at absolute zero while keeping their vital proteins from unfolding in intense heat. These environments are exceptional challenges rather than normal habitats. but they show how a single protective shield can safeguard an animal at both ends of the thermal scale. Number 7, we must look beyond extreme environments to a silent threat that destroys the genetic blueprint of life: ionizing radiation. While a dose of just 4 gray is fatal to humans, these microscopic animals survive radiation exceeding 1,000 gray, with some species enduring up to 5,000 gray. This is over 1,000 times the lethal human limit. Such intense energy rips through double-stranded DNA, fracturing chromosomes into small fragments. For almost any other organism, this damage is irreversible, leading to swift death. Yet, the water bear persists. It does not possess a physical shield. Instead, it relies on a complex molecular defense. When exposed to radiation, the animal deploys powerful antioxidant enzymes that neutralize destructive free radicals before they can damage the genetic material. If the DNA does break, the water bear activates a rapid repair pathway upon rehydration, stitching its genome back together. Proteins bind directly to the chromatin, holding the broken strands in close proximity so they can be reassembled without introducing fatal mutations. This extreme tolerance peaks when the animal is dried into a tun, where the absence of water limits the formation of harmful reactive oxygen species. In its active, hydrated state, the creature is far more vulnerable. Its survival is a precise molecular defense. Number 6, the theoretical limits of biological endurance faced a definitive test, not in a terrestrial laboratory, but in the freezing vacuum of low Earth orbit. On September 14, 2007, the European Space Agency launched the Photon M3 mission from Baikonur, carrying 3,000 dried water bears of the species Milnesium tardigradum. These specimens were mounted on the external Biopan 6 platform, completely exposed to the elements. For 12 days, the dried animals endured the raw vacuum of space, absolute temperature extremes, and intense cosmic radiation. It was a real-world test designed to determine if a multicellular animal could survive the ultimate environmental vacuum. When the capsule returned to Earth on September 26, scientists immediately rehydrated the specimens to check for signs of life. The outcome surprised the scientific community. Over 68% of the vacuum-shielded specimens revived within 30 minutes of rehydration. These individuals resumed normal behavior, fed, and successfully produced healthy offspring free from genetic damage. Even under the harsh glare of full-spectrum solar ultraviolet radiation, 10 to 15% of the specimens survived, with several individuals reproducing normally. Co-researcher René Demetz remarked that nobody had previously known about such extreme biological capabilities in space. This landmark flight helped transition water bears from laboratory curiosities to verified cosmic survivors, providing the first real proof of multicellular endurance in orbit. Yet, their space survival carries an important distinction. Only the desiccated, shielded individuals thrived. Direct solar ultraviolet still proved lethal to most. In the 5th place, the mystery of the water bear expands from surviving extreme laboratory conditions to enduring vast epochs of geologic time. While individual specimens survive freezing or radiation for weeks, their entire lineage has persisted on Earth for over 500 million years. This means tardigrades existed long before the first dinosaurs walked the Earth, predating almost every iconic animal group we know today. Molecular clock analyses trace their origins back to the Cambrian explosion, a period of rapid evolutionary divergence 500 million years ago. Since that ancient dawn, our planet has undergone 5 catastrophic mass extinction events: cosmic impacts, runaway volcanic activity, and sudden ice ages that wiped out up to 96% of all marine species. Yet, the ancestors of the water bear quietly endured every single global collapse. They survived these world-ending crises using the same cellular armor that researchers study under microscopes today. By slipping into their metabolic pause when oceans turned toxic or temperatures plummeted, they outlasted the catastrophes that brought down empires of larger beasts. This survival represents a 500 million-year legacy of absolute persistence. Number 4, we must separate science fiction from real biology. Despite their legendary reputation, water bears are not immortal. In their active, hydrated state, they are surprisingly fragile, crawling through damp moss with no special physical armor. This makes them easy prey for snails, microscopic mites, and even other carnivorous tardigrades. They cannot simply shrug off every everyday hazard. If they do not have time to transition into the dried ton state, a sudden spike in temperature or a mechanical crush will kill them instantly. Their famous tolerance is not a constant passive shield, but an emergency escape hatch that requires precise environmental cues to deploy. Without these protective circumstances, their cellular defenses fail. Real biology exposes a stark limitation. These animals do not exist in a permanent state of invincibility. They are extraordinary survivors, but they remain mortal creatures bound by the physical laws of life, vulnerability, and death. Number 3, the legendary folklore that transformed a microscopic animal into a global pop culture icon of near immortality. Over the past several years, public science storytelling took the astonishing laboratory data of tardigrade survival and spun it into a viral phenomenon. Television series like Cosmos introduced their extreme adaptations to millions of homes, presenting them as ultimate survivors. Online videos quickly followed, capturing millions of views and framing the water bear as an indestructible creature that could shrug off any cosmic disaster. This cartoon-like reputation soon escaped academic circles. They made cameo appearances in animated television shows like South Park, and tattoo parlors reported an unexpected rise in clients asking for permanent water bear illustrations on their skin. People adopted them as a modern symbol of personal resilience in the face of hardship. Yet, this cultural legend relies on simplified facts, ignoring the stark contrast between their vulnerable active state and their dormant phase. This framing represents a shift from animal physiology to human imagination. Stripping away the folklore reveals a far more fascinating scientific reality. Once we look past the internet memes, we must confront the unresolved biological mysteries of their survival. What fundamental cellular mechanisms are operating behind the scenes to shield their delicate tissues from complete destruction? The answer lies not in myth, but in a series of extraordinary molecular discoveries. In second place, we transition from outer space to the microscopic architecture of the cell, where a real molecular mystery awaits. For decades, scientists wondered how these creatures could survive intense radiation and dehydration without their genetic code dissolving into chaos. In 2016, researchers sequenced the genome of an exceptionally resilient tardigrade species and discovered a completely unknown gene. It codes for a protein found nowhere else on Earth, named damage suppressor, or DSUP. This protein acts like a physical shield, binding directly to chromatin and wrapping around DNA to block destructive particles. When researchers engineered human kidney cells to produce this tardigrade protein, X-ray damage to the human DNA dropped by nearly 40%. But the DSUP protein is only one piece of a much larger biological shield. Cryptobiosis research indicates that water bears do not rely on a single defensive trick, but rather a complex system of overlapping safeguards. When dehydration begins, they produce distinct disordered proteins that transform the liquid inside their cells into an amorphous, glass-like state, halting all cellular decay. This vitrification process preserves delicate cell structures in suspended animation. Yet, how these molecules work in perfect harmony remains one of biology's greatest unresolved questions. Scientists still cannot explain exactly how these cells avoid fatal damage during the drying process, or how they safely coordinate the cellular reboot during rehydration. This hidden molecular machinery remains a profound scientific enigma, proving that the closer we look, the more secrets these tiny animals hold. And finally, in first place, the ultimate value of the water bear lies in its potential to reshape the future of human medicine and space exploration. Biologists no longer view this microscopic organism as a simple evolutionary curiosity. Instead, it serves as an active, living blueprint for for technological breakthroughs. At MIT, researchers are engineering human cell lines to express the tardigrade's DSUP protein, aiming to reduce collateral DNA damage in cancer patients during radiation therapy. In biotechnology laboratories, scientists are using tardigrade proteins to protect synthetic cell-like vesicles, ensuring they retain functional enzymes after being completely dried out and rehydrated. This discovery could revolutionize vaccine preservation, allowing life-saving medicine to be distributed globally without the need for expensive refrigeration systems. The implications stretch far beyond the boundaries of Earth. In astrobiology, the tardigrade's survival in vacuum supports the panspermia hypothesis, suggesting that basic life could hitchhike across interplanetary distances inside meteoric rock cracks. This extreme resilience has forced space agencies to enforce strict planetary protection protocols, ensuring that our exploratory probes do not accidentally contaminate the pristine, icy environments of Europa or Enceladus with indestructible earthly organisms. Yet, the ultimate mystery remains unsolved. Scientists still do not fully understand the precise molecular choreography that allows these cells to safely reboot their entire biological system after decades of absolute stillness. The closer we look, the more we discover that this tiny animal holds the keys to long-term preservation, interplanetary travel, and the very limits of biology. Subscribe to see more creatures that defy nature videos. Across these 10 entries, a singular truth emerges. The water bear's ultimate survival weapon is absolute surrender. By suspending their own biology, these tiny creatures redefine the boundaries of life itself. They prove that enduring the impossible isn't about fighting the environment, but pausing to let it pass, a mystery we are only beginning to decode. Subscribe for more incredible science discoveries.